Today we'll talk about the first lesson in the secondary about the calculus, which is the geometrical interpretation of the rate of change or the first derivative. Let's see, let the given figure like this represent the curve of the function y equal f of x, and the 2 points A and B are 2 points on it, where A, its coordinate is x1 and f of x1, and the coordinates of the point B, x1 plus h and f of x1 plus h. Okay? Then AC, this is the horizontal distance between the 2 points A and B, which call delta x or h. And BC is delta y, the difference between the coordinates of the point A and B. And we have a straight line AB, which is called secant of the curve. Then we know that the slope of the straight line is the angle, the tan angle between this straight line and the horizontal line, and we called it alpha. Okay? Let's see that tan alpha equals, in the triangle BCA, the opposite over the horizontal line, BC over AC. So we noted that BC is f of x 1 plus h minus f of x1 over the horizontal distance, which called h. So we know that the slope of the straight line AB is the tan alpha, which is its angle between this straight line and the horizontal line AC, equals f of x1 plus h minus f of x1 over the h. Okay, let's see now if A is a fixed point, and we imagine that the point B moves on the curve to this function toward the point A. Then what happened? Then point C moves toward A also. So the h tends to 0. The horizontal distance between A and C tends to 0. So AC equals h tends to 0. So the straight line AB, which is a secant, tends to or towards to be the tangent to the curve AY equal f of x. Then the slope of A, the tangent equals tan theta. What is the theta? The theta now, this is the angle between the tangent of the curve and the horizontal line at the point A. Equals limit of f of x1 plus h minus f of x1 over h, when h tends to 0, because this line, the distance between point A and B will be approached to 0, so not equal 0. Point A not equal the point B, but it's approached to each other. So now we know the meaning of the slope of the tangent of any curve at a given point equals limit of the f of x1 plus h minus f of x1 over h when h tends to 0. So this is called the geometrical meaning of the differentiation, the calculus. Okay? The first derivative of the function, the first derivative of the function expressed by the limit of f of x 1 plus h minus f of x over h when h tends to 0. Okay? This is have a unique value at every value of x, and we denote it by several meaning, so different samples, like we called it first derivative by different sample like this, dy by dx, or y dash, or d by dx of f of x, or f dash. Okay? Now we must know that dy by dx is a mathematical expression. This is meaning a mathematical expression, not defined as a quotient of dy by dx, but it's meaning that the derivative of y with respect to x. Okay, let's see now rules of differentiation. Theorem 1. Theorem 1 about the differentiation say that if we have f of x equal a, f of x equals a, and a is any number belongs to real numbers, that means if I want to find f dash, which called it the first derivative of the function f of x, equals f of dash of x equals 0. So any function is a constant, the differentiation, the first derivative of this function will be equal 0. Okay? Let's talk about the theorem 2. Theorem 2, if f of x equals x power n, where n belongs to real numbers, then f dash of x, the first derivative of this function, will be equals n x to the power n minus 1. Okay? Let's see some examples about the first derivative of any function like we talked about it now. Example, find y dash of each of the following functions. What is the meaning of y dash? Y dash is the first derivative of the function y. Okay, the example number 1, y equal x power 5. This is the function y equals x power 5. This is a constant function? No, because it have a variable x. So we take the theorem number 2, which is how we get the function. Yes? How we get that first derivative? Y dash will be equals 5. We take the power 5 and we multiply it by the x power 5. Then we decrease the power by 1. 5 minus 1 in the power. So the final result will be 5x power 4. Then the second example, number B, y equals 1 over x power 3. How we get this function, this first derivative of this function? So the first step, we must organize this function like this. Y equals x power 3? No, we must change the sign of the power, because we know that any samples with power in the denominator, if I remove it from the denominator to the numerator, we must change its sign of the power. The power here 3, so the power will be negative 3. This is the first derivative? No. This is the organization of the shape of the function. So we know now we get the first derivative y dash of this function. By the same way we take it before. We take the power negative 3 and we put it beside x. We write x as it is, then we subtract the power by 1. So we put negative 3 minus 1. Then the final result will be negative 3x power negative 4. We put the power with negative power 4 as it is in the power? No. We must put it in the simplest form, which is the power is positive. How we put it in the power is positive? We put it in the denominator. So we write it as it is, negative 3 over x power 4. This is the simplest form. Now we talk about another example, number C. Y equals square root x power 3. We must organize this function like we do it before. How we put y? Y will be equals x power 3 over 2. How we get this power? We know before how we express the roots by fractional form, power 4. How we get it? The power, the inner power over the outer power. X will be to the power 3 over the power of the root is 2. Then we find first derivative of the function like this. Y dash will be equal 3 over 2 and x power 3 over 2 minus 1. Then the final result will be 3 over 2 x power half. Okay, then we remove this fractional form of the power to the root like we do it before. Equals 3 over 2 square root x. Why square root 2 is square root x? Because the inner power will be 1 and the outer power will be 2 to the square root of x. Let's see number D, another example. Y equal 1 over cubic root x power 2. Now we write y as exponential form. 1 over cubic root x power 2. How we to form this function? X to the power 2 over 3, but it is in the denominator. We put it in the denominator. We change the sign of the power. So y will be equals x power negative 2 over 3. Now we can find the first derivative of the y. Y dash will be equals negative 2 over 3 x power negative 2 over 3 minus 1 and will be equal negative 2 over 3 x power negative 5 over 3. Like we do it before, we must remove the negative in the power and we search about the root will be in the power. We change the power, the fractional power into root. Okay, now we put it in the simplest form, which is negative 2 over 3 multiply cubic root x powers 5. Okay, let's see another example. Y equal x power 2 over 4th root 2x. We put it in the simplest form. Y will be equals x power 2, which is in the denominator, multiplies x power negative, the inner power 1 and the outer power 4, 1 over 4. So we have the same base and there is a multiplying between them. So we must add the power. The result will be x power 3 over 4. We add 2 to negative quarters, the result will be x power 3 over 4. 7 over 4. The power 2, negative 1 over 4 will be 7 over 4. So the final result of y equal x power 7 over 4. Now we find the first derivative. Y dash will be equals 7 over 4 x power 3 over 4. We must change it to the root because we have a fractional power, exponential power, so we put 7 over 4. What is the inner power and the outer power? The inner power will be 3. So x power 3 under the fourth root. So the final result, y dash will be equal 7 over 4, the fourth root, x power 3. Then we have another example, y equal x power 2 cubic root x power 2. So we must put it in the simplest form. X power 2 multiply x power, the inner power 2 and the outer power 3. 2 over 3. We have the same base, we must add the power. So the simplest form of the function, y will be equals x power 8 over 3. Now we can get the first derivative of this function. Y dash will be equals 8 over 3 x power 8 over 3 minus 1 will be x power 5 over 3. We change the exponential function power into roots, will be now 8 over 3 to what is the inner power and the outer power? The inner power will be 5. So x power 5 under the cubic root. Now we talk about y equals square root x. Like we take it before, we put it in the exponential form, exponential power. The y will be equals x power, the inner power 1 and the outer power 2, x power half. So we can find the first derivative y dash equals half, and we put x at the power half minus 1 will be negative half. And we remove the negative sign by taking it in the denominator. So y dash will be equals 1 over 2 square root x. You must notice that any